Here's the second of my two videos on solving systems by substitution. In this example, I have two equations and I'm trying to find the solution to this system of equations. Previously, I could just take a value and substitute it into the other equation, such as this example from my previous video where x equaled y minus 2, so I can just substitute y minus 2 in for x in my other equation. Well, here it's not that simple because I haven't solved for any variables. I have to choose an equation and choose one of the variables in that equation to solve for. It doesn't have to be y in both equations or x in both equations, but I just want to make my life easier. If I look at this, I can see that the x in my first equation is going to be the easiest to solve for because all I have to do is add 2y to each side, and once I solve it, I don't have to deal with any fractions. I want to deal with fractions as little as possible. So once I'm here, I now know that x equals negative 6 plus 2y. So I can go back to my other equation, and instead of writing the x, I'm going to substitute in what I know x is equal to. And from here, it's just a matter of simplifying. I distribute my 4 in. And then I can combine some like terms. Negative 24 equals 14y, 24 plus 14y equals 4. And then I'm going to add 24 to each side just to solve this equation. I get that 14y equals 28. From there, I'm dividing by 14 on each side and get that y is 2. Well, I know the y value of my solution. Now I just have to go back and find the x value. So if I come back to my other equation, I can use that now. But instead of y, I now know that y is 2, so I'm going to substitute that 2 in for y. And now I'm just simplifying. Negative 6 plus 4 is negative 2. So if I were to graph these two lines, by solving them for y, putting them in slope-intercept form and graphing, they would intersect at the ordered pair, negative 2, 2. And so that's how you solve a system of equations when both equations are in standard form. You have to pick a variable. I chose the x because it's the easiest to solve for, and then go from there.